Every day, to heat our homes, we have to burn fuel, such as wood, pellets, methane or diesel. By doing this, without realizing it, we are introducing into the atmosphere large quantities of CO2 and other polluting substances, all very harmful to the health of all living beings, and fostering the greenhouse effect on the planet. Fortunately, today there are more virtuous heating systems based on the use of renewable resources, like low-temperature geothermal energy, a form of energy exploiting the heat coming from the most superficial layers of the Earth, making it possible for us to keep warm in a natural, environmentally friendly way. But how does this innovative heating method work? Let's find out together. First of all, you must consider that the Earth is structured into 3 layers, just like a hard-boiled egg, to put it simply. The crust would be the eggshell. It is a few dozen kilometers thick and is composed by relatively low-density rock, while below it we find the mantle, the egg white, denser than the crust. At the center of our planet we have the core, comparable to the yolk, even denser than the previous layers. As we move from the crust towards the center of our planet, the temperature gradually increases, following a specific parameter, known as geothermal gradient, until it reaches 5,000 to 6,000 degrees centigrade in the center of the Earth. This deep heat rises vertically towards the crust, generating, in special geological conditions, volcanic and thermal phenomena on the Earth's surface, which can be quite spectacular, like those we can observe in Iceland, for instance. In these particular cases, this heat, sometimes higher than 100 degrees centigrade, coming from deep underground, may be harnessed to produce electricity. In these cases, we talk about high-temperature geothermal energy. There is also a low-temperature geothermal energy that, in completely normal geological conditions, allows us to use the heat naturally found underground much closer to the surface. With low-temperature geothermal energy, the outer part of the Earth's crust is used as a heat reservoir to heat our houses. Just like a lake may be used as a water reservoir to irrigate a field. If the field is at a higher altitude than the lake, we have to raise the water's initial level with a water pump using electricity. In the same way, using a relatively simple machine, we can raise the initial heat source found underground, usually around 12 to 13 degrees centigrade, to a higher temperature suitable for home heating. This machine, powered with electricity, is called a heat pump because it is conceptually akin to a water pump. It works like an everyday home fridge, exploiting the circulation of a cooling fluid. This continuously travels along a precise route, at first through an evaporator as low-temperature gas, where it absorbs the heat conveyed from the ground, then through a compressor, which increases the temperature of the previously absorbed heat, and finally through a condenser, where it releases the energy produced as heat. So, during the winter, the heat underneath the ground is picked up using boreholes and later brought to the surface. The heat pump increases the initial heat absorbed from the ground to a temperature that may be used to heat an entire home. During the summer, by inverting the heat pump cycle, heat is removed from the building, which is therefore cooled and returned underground, consequently heating the soil. This process is much more efficient than the use of the heat contained in the air or in the waters of a river, because temperatures underground are a lot more stable, as they are not influenced by variations in the atmosphere, so they constantly remain cooler in the summer and warmer in the winter than the air's temperature. In summary, a geothermal energy system is composed of vertical boreholes from 100 to 150 meters deep, specifically equipped to intercept heat underground and send it to a heat pump on the surface, which will increase the heat contained in the most superficial layers of the Earth to a temperature high enough to be used for central heating. Later, the heat is distributed inside the building through radiator panels, for instance. The use of geothermal energy systems for heating and cooling buildings is a responsible choice for the planet. The use of heat as an energy source allows us to reduce polluting emissions in the atmosphere to zero, thus limiting the effects of global warming on the environment. Geothermal energy heating systems, unlike those employing liquid fuel, cannot pollute the soil, thus avoiding the risk of contaminating groundwater. Finally, low-temperature geothermal energy is a form of free energy, always available anywhere, and in practically unlimited quantities. To promote the use of this technology, 12 partners on the Alps have established Project GRETA, near-surface geothermal resources in the territory of the Alpine Space, an operation co-financed by the Alpine Space Programme of Transnational Cooperation 2014-2020, with the aim of improving the sustainable use of low-enthalpy geothermal resources to achieve a substantial reduction of CO2 emissions. Do something good for yourself and the planet. To keep warm, use geothermal energy.